Here's an intriguing little problem. Number 1, we have a perfect cube. This tells us that each length is the same value as the other lengths. If it's a cube, we have a mass, we have a density, and we are to determine the length of one dimension of the cube. In other words, how long is that, or that, or that, or that? So it looks like the first thing we have to do is figure out the volume of the cube, because we're only given the mass and the density. So, if we remember our density equation, if density is equal to mass divided by the volume, then we could also remember our density mobile. And remember that if we want to solve for volume, then volume is equal to mass divided by density. We have a mass of 110.7, and we'll divide that by 4.1, and our volume is 27 centimeters cubed. Now, if this is the volume, and this is a perfect cube, then some number times itself, length times width times height, and all the values will be the same because cubes have dimensions that are all the same value. This times this times this will give us 27. If we substitute a 1 in for x, 1 times 1 times 1 equals 1, so 1 is not the answer. If you substitute in a 2, 2 times 2 is 4, 4 times 2 is 8, 8 is not the answer. Plug in a 3, 3 times 3 is 9, 9 times 3 is 27. Or you could get all calculatory and spiffy, and you could plug 27 into your super calculator, and you could figure out its cubed root, and you would find out that the length of a side is equal to 3 centimeters. There's your answer. Number 2, we have a mass and a density, and it's asking how much water this thing would displace, which basically tells us to figure out the volume. We can use the same equation as we did before. Volume equals mass divided by density. Here's the mass divided by the density. The volume is 5.6 centimeters cubed, or milliliters, either or. Probably centimeters cubed because it's solid. Number 3, you are given the density of aluminum which contains a hidden ordered pair. Remember, this means 1 centimeter cubed of aluminum has a mass of 2.7 grams. Create a mass versus volume line graph. So this number and this density value alone can be translated, believe it or not, into a line graph. Mass, volume. Put a 1 here and make this 2.5. Now all we have to do is plot this point over to 1 up to 2.7, connect. And this is our line graph for aluminum. And now we're going to plot in another line for water. You see that a blue marker has appeared out of nowhere, and we know the density of water is 1.0 grams per centimeter cubed. So if we go over to 1, we estimate where 1 would be. This would put us about here. There's our water. Number 4, a series of volumes and a series of masses. And you're now asked to draw substance A and substance B. Here's substance A, here's substance B. Matter is to be represented with dots. Make the dots in the sample same distance apart from each other. So it appears as if sample A has a volume of 1 centimeter cubed. Sample B has a volume twice that. We might think of it this way. And we have 5.1 grams and 10.2 grams. And notice the dots are approximately the same distance apart because they are the same material. Given this incorrect line graph, where a student set up the axes incorrectly but then correctly plotted all of the data, determine the density of the substance. So the student put volume here and set up the numbers, and then put mass here and set up the numbers, and then took the actual data and plotted it accurately on a reversed graph. So it looks like if we go over to 1, we could go up and find out what the volume is. And if that's 5, then this is somewhere between 5 and 6. So I'm going to estimate that this is equal to perhaps 5.5. So we have a volume of 5.5, which corresponds with a mass of 1 gram. Our density is 0.2. And as I'm reviewing this question, I'm thinking it might be a little confusing to interpret what it is the question is actually asking. So if you did it a different way, I don't think that's your fault. I say, blame the ducky.